Welcome to my first devlog. Well, why am I going to do a devlog? I wanted to put everything that I have done so far in this channel into practice. It is good for me, it is good for the viewers. I will discipline myself into implementing the ideas I have, and the viewers will get motivated to do the same, to mix all of these skills that we have into creating something that maybe improves some aspects of our lives, right? With this video, but I had a problem. I didn't know what to do, what to implement. The other day, as I was cleaning up the apartment and thinking about why don't I have a friend, all of a sudden I thought about an idea. I went to ask Alexa if she can be my friend. Alexa, I need you to be my friend.
I'm not quite sure how to help you with that.
After Alexa got my heart broken, I decided maybe I can build one. After doing some research and asking ChatGPT, I eventually came up with this model. In this model, I'm going to have an IoT, which is the Internet of Things. It is going to be my device, which is not Alexa. And it is going to have a microphone, streams the audio to a graphical gateway installed on the IoT, and then will send the data to a wake-up handler. What is a wake-up handler? Well, basically, it is the handler which wakes the device up to start processing your audio. And then after the wake-up handler detects a specific name, for example, or a wake-up phrase, it is going to send this to our speech-to-text service, which is based on Python, and it is going to generate the transcript from the audio for us, which is the text, and the text is going to be sent out to a command processor, which is going to be outside of the device, probably on our cluster, Kubernetes cluster. We are going to send the data through gRPC and then get a stream of data back through gRPC as well, and then do a text to a speech and send it back to the client, well, like to the speakers and so on. Well, obviously, we are not going to have this much of complication from the beginning when we are going to start. So what I'm going to have, instead of just this microphone interface with, like, for example, with Python or something, I'm going to actually have a UI. So I'm going to design a UI which is going to get the microphone from the browser, like read the medias from the browser, and it's going to access the microphone, and then it's going to use the WebSockets to send to subscribe into GraphQL and then send the data. Since I am always very confident about my programming skills, I decided to do the GraphQL service in Golang rather than C#, which I'm really good at. Well, Golang is very performant, it has good gRPC support, so these were motivation to do it, and I had one project in Golang, so I said, why not? So for GraphQL in Golang, I found this library. It is called gQLGen. Apparently, this is a library which is pretty famous. I went for it, and okay, my GraphQL server is running in Go. I'm very happy right now because yeah, this is the first time I'm doing Go and GraphQL, and I have a mutation. So with gQLGen, it is a schema first. It is only a schema first, and now I have a mutation. I'm going to have now a subscription, see how WebSockets works, and then at the end we have to we have to stream the generated text from our speech-to-text model back to the UI. That would be ideal for this video. Do you know what I just realized? Or remember, GraphQL subscriptions are bidirectional, which means you just get the data from server to client.
No, God! No, God, please, no! 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 No!
It's for broadcasting some notifications. That's what they are for. And this brings me to the idea that why from the first place I chose GraphQL. How did I do this mistake? So we don't really need GraphQL, we just need a simple raw WebSocket connection. And then with that, we can send our chunks of audio to the backend and then receive the response. Of course, we can use GraphQL, but then you have to do it with the mutations. And for each audio chunk, you have to do another call. And I really don't want to do that. Well, this means we have to change here. The GraphQL gateway has to go away. then we need just a normal WebSocket session. And that should, and it is WebSocket. Yeah, let's do that. Now I have a basic WebSocket server running. If I connect to this, I'm gonna get the connection, and right now I only handle one type of message. So what will happen is that we are going to also have data here, and our audio data is going to be base64, and then we are going to receive this and then pass it through gRPC to the Python service. Let's do that now. Okay, now I'm getting a bit tired, but let's go on. Now so we have the WebSocket service in Go up and running, and let's now do the Python service. The Python service is going to be the one which is responsible for getting a gRPC stream of audio chunks, now either in base64 or like in bytes, and then it is going to transmit back the generated transcripts. Let's set this up. I found an interesting library. Faster Whisper is the library which is faster than the OpenAI's Whisper. This is based on that, and it uses less memory, which is perfect for my case with the Raspberry Pi. And I'm going to use the large model, but on my Raspberry I think I'm gonna go with a small one, but depends. Let's see if the Faster Whisper supports it too. Yeah, let's start. What could go wrong, huh? So now I have my server, gRPC server for Python. As you see here, I have a listener service which listens, and it's going to get a listener request, which is going to receive the audio chunks, and at the end it's going to send back text and is final as the response. So my listener service basically is just going to use the large V3 model from Whisper, and it is going to give the audio segments to the model and generate the transcripts, and then at the end yield it back to the client. And in my Golang, where we had the speak, I actually changed it to listen. And then in the handle listen, I basically just get the message, convert it to byte, and then send it as the audio payload to my gRPC server. And on the speak, it is when I'm receiving something back from the stream. It's like I listen to the stream. This is it is just a loop. It doesn't end. And then as soon as the client is created, I just start this loop as a Go routine, and then any response that comes back, I just navigate it back to the client. Well, now this should work. The only way to test this, it is with the UI. So let's get it done. So as I just said, what could possibly go wrong? Let's see what went wrong. Okay, now I have a bunch of errors with CUDA and so on. So let me try to fix this, and it is when I thought it is going to be no problem and easy.
Many minutes later.
Okay, after some debugging, it is doing a transcription, but for some reason it's just sending back thank you. Yeah, let's fix this. Okay, so now it is 10:39 p.m. and I am really tired. And as you see, it is transcribing what I'm saying. The problem was that the default media recorder from the browser was not getting the PCM format of the audio. So it was breaking when it was getting to Python, because Whisper expects PCM, and as you see, it's a little bit stupid right now. So it says so like Ray Kinkman, who the hell is, but doesn't matter. We got what we wanted, and I want to improve it, but this is going to be this for this video, and I have to go to bed. And we'll see you next time, and we are going to go on, probably going to fix this and add the wake up handler and clean up a little bit of code to see how can we improve things. before I go to bed, please make sure you hit a thumbs up if you like the video. If you're not a subscriber, subscribe if you want to see what will happen next. I'm pretty interested. I'm gonna continue the series and add whatever I said I will add. For sure I'm gonna do that, but for now I'm done. So for real, I'm gone. Bye.